Hello students, good evening, welcome to the session. Today we'll discuss about circles and equations of the circles, and like common chord, the tangent to it, and various conditions of the center of the circles, and a point related to the circle, whether the point lies inside the circle, outside the circle, right? And we'll solve some problems basing on these concepts. Okay, so let us begin. We all know, right, like circle is nothing but set of points from a fixed point, a collection of points which are equidistant from a fixed point. This fixed point is nothing but center, and this equidistance is nothing but the radius, and these all points, these all set of all these points is the circle. And this one, the place inside is called as the interior region of the circle, and this is the exterior region of the circle. So if you say something like a point is there on the circle, it's like here, if I say A is a point on the circle, the point should lie on it, right? And we already know, right, like that the equation, before talking about that, the distance between 2 points, suppose there are 2 points, say x1 y1 and x2 y2 in coordinate geometry, in the rectangular coordinates we have learned, right, like the distance between these two will be equal to x2 minus x1 whole square plus y2 minus y1 whole square under root. This will be equal to the distance. Now I want to find out the equation of the circle. So I will take a random point x comma y on the circle. It's a point, a variable point. X is varying and y is also varying. It keeps going around, right? And the distance from the center, we know that it is equal. The distance of any point on the circle is equal to the radius. So this is equal to this. And let us say the center is, say, some h comma k. Right, then what will be the equation of the circle? We know that the distance between these two will be equal to the radius, right? So x minus h whole square plus y minus k whole square under root will be equal to the radius r. In simply, we can also say x minus h whole square plus y minus k whole square is equal to r square. This is the standard form of the circle, where h comma k is the center and r the radius. H comma k is the center and r is the radius. Suppose if you are talking about the center at the origin, like 0 comma 0 is the center, then our h and k will become 0 and our equation will be x square plus y square, which is equal to r square. This is the equation of a circle, the general form of the equation of circle when the center is at the origin. And this is the equation of the circle when the center is at h comma k. Right, now there is another standard form of equation of the circle, which generally we write it in the form of x square plus y square plus 2gx plus 2hy plus c is equal to 0. This is also an equation of the circle. So how is this an equation of the circle? You can write this as x square plus 2gx plus g square minus g square plus y square plus 2hy plus h square minus h square. I'm adding, means I'm trying to complete the squares, plus c equals to 0. Then I can write this one as x plus g whole square plus y plus h whole square minus g square minus h square plus c is equal to 0. Then this can be written as x minus g whole square plus y minus h whole square is equal to g square minus h square, g square plus h square minus c, because when you send these two will be positive and that will be the negative value. right? So now if you compare this with our earlier equation, like x minus h whole square plus y minus k whole square is equal to r square, here center is minus g comma minus h, or minus g comma minus f, any alphabet, whatever alphabet you take there, right? And the radius r square is equal to g square plus h square minus c. So simply the radius can also be written as root of g square plus h square minus c is the radius of the circle, when the equation of the circle is x square plus y square plus 2gx plus 2hy plus c is equal to 0. So this is one more standard form of the equation. See how it is, for example, it saves time. It's nothing new, like it's the same equation which is expanded, but it saves time when you are given, say suppose they will ask you in the exam, say they give a question like x square plus y square minus 8x minus 7y plus 6 is equal to 0, and they ask you to find the radius of their circle. Then you cannot sit and complete the squares and do it. It will take a lot of time. So what is the radius? G square plus h square minus c. So now you have to figure out what is g square, what is h square, and what is c. So you can write this equation on the top, like to compare the things: x square plus y square plus 2gx plus 2hy plus c is equal to 0. And when you look at this g, so 2g is equal to minus 8 and 2h is equal to minus 7 and c is equal to 6. So from this you can calculate g as minus 4 and h as minus 3.5 and c is equal to 6. So you can simply write it as 16 plus 12.25, I guess 3.5 and 3.5 would be I think 12.25 minus 6, and you simplify this and this would be your radius straight away. So instead of doing all this, like we have a general rule where you can easily identify the center. Even if you can identify the center also, like what is the center of this, again it's not like okay you have to change it into this form and then find it. It will take a lot of time. When this is given, your time is very precious, right? You can directly say like minus g comma minus h is the center. So here 4 comma 3.5 will simply be the center of the circle for us, right? So this is one more standard equation which will save our time a lot, right? Now, so what can we say about this circle? Say suppose I have a circle x square plus y square, say plus 2gx plus 2fy plus c is equal to 0, right? We know that the radius is equal to root of g square plus f square minus c. This would be the radius. Now when I have, see, I have a circle, right, and I have a point. So there is no, so point means like this is also, it's a dot. So is there any radius here? There is no radius. So in this the radius will be equal to 0. In this case, when there is no, it's only a point, then the radius will be equal to 0. And this is not the circle, okay, this is, I'm just talking about the point. I'm circling it to say that this is the point, and here this is the radius which is some real value, right, some real number. So that means r greater than 0 will give us a real circle, means existing circle, real circle in the sense like which is existing, which you can draw, which we can physically draw. So r is greater than 0 means g square plus f square minus c under root should be greater than 0. In other words, g square plus f square minus c should be greater than 0, or simply g square plus f square should be greater than c. Then I have a real circle situation. I will have a real circle, right? If radius is equal to 0, then g square plus f square should be equal to c. Then this will become 0, right? Then it is a point. It's not a circle, there is no radius at all, so it's a point. Similarly, when you have g square plus f square minus c is less than 0, means the value of r is, means this inside value is negative, then there is no radius, no real radius. This is imaginary radius. So radius is imaginary. So there is no real circle. The circle will be imaginary, like, yeah, we don't know like in which dimension it goes, but it is a imaginary circle. There is no real circle because the radius itself is imaginary, right? So like discriminant, like we do in quadratic equations, right? Like the discriminant we do when the discriminant is greater than 0, we have real roots, real and unequal roots are distinct roots, you can say. And when the discriminant is equal to 0, then you say that the roots are equal, real and equal roots, like the repeating roots you will have. And when it is negative, then you go into the complex numbers like imaginary roots. But here we're not talking about that. So it's just about the circle, whether it exists or it's not existing. Not existing is just a dot or a point. Existing is a circle with some radius. It has some radius, some real radius. How do you have the real radius? When g square plus f square is equal to is greater than c. When it is greater than c, g square plus f square is greater than c, your radius will be real number. It's a positive real number, and you can draw the circle, right? Then how can we say that a point or anything, say suppose I have a circle with center, let us name this circle as S, and which is equal to x square plus y square plus 2gx plus 2fy plus c. This is a circle which is equal to 0, right? Circle equation. This is the standard equation of the circle. Now I have a point x1 y1. The point is not here, it's somewhere here. So I don't know where the point is. So I want to know whether this point is inside the circle, outside the circle, or on the circle. So how will we know that? Is like you have to substitute this point in the equation of the circle. So that is sx1 y1 you do. That is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c is greater than 0, then the point is outside, equal to 0 plus 2gx1 plus 2fy1 plus c is equal to 0, then it is lying on the circle. And x1 square plus y1 square plus 2gx1 plus 2fy1 plus c is less than 0, then it is lying inside the circle. For example, let us take one small equation, say x square plus y square minus 4x plus 6y plus 5 is equal to 0, and I want to check whether say 3 comma minus 2 is a point inside the circle or outside the circle. Just you substitute the values there. 3 square plus minus 2 whole square minus 4 times 3 plus 6 times minus 2 plus 5. You calculate this value, like 9 plus 4 minus 12 minus 12 plus 5. Now this is minus 24, and this is plus 18, so this is definitely less than 0. That means this point is lying inside the circle. So you just need to substitute the value of that particular point. Like you take that x1 value and y1 value and place in the circle's equation and see whether it is falling inside or outside by just checking these 3 conditions. Okay. Then circles, if there are two circles, what are the possible conditions for them? 2 circles can be away from each other, not even touching. The center is C1 and the center is C2, and say this radius is R1 and this radius is R2. Then the distance C1 C2 will be less than radius 1. I'm sorry, it should be greater than radius 1 plus radius 2. when, because see, distance between C1 C2 is this entire thing, right, this entire thing, but R1 and R2 is the parts which is missing out this region. So here C1 C2, the distance between C1 and C2 should be greater than R1 plus R2. When two circles are touching each other, say C1 and C2 again, and this is R1, this is R2, then here C1 C2 will be equal to R1 plus R2. The distance between the two centers will be equal to sum of the radii of the two circles, right? And when there are two circles intersecting each other, C1 and C2, radius 1, radius 2. So here C1 C2 will be less than R1 plus R2, because the C1 C2 distance is when you're adding R1 and R2, you are adding this bit one more time, like this is the part again, you know, missing in this. Earlier this part was missing in R1 plus R2, but here this part was missing in between C1 and C2. And there is something like, you know, a circle can be this way also, right, touching from inside. So in this case C1 C2 will be equal to R1 minus R2, where R1 is the radius of the bigger circle and R2 is the radius of the smaller circle. So if you subtract that, you get the distance between these two, the two centers, right? So this is the this is how you find whether the circles are touching each other, or, you know, intersecting each other, or, you know, touching internally or not touching internally. So how will you do that is, like, you have to find the distance between the two centers. You can from the, you know, equation of the circle, you can easily find out the center of the circle, like we already know the standard forms, and you can find the center of the circles. And then the distance between the two centers, when you know the 2 points, the centers, you can find the distance, and you already know the radius, then you can easily identify whether the circles are touching or not touching, or touching externally, touching internally. You can easily find out, right? Next, when there are two circles are intersecting each other, say like this, and say this one is the center 1 and this one is center 2, and you have a common, what is a chord? Chord is nothing but a line segment which has its endpoints on the circle, right? So this is the common chord. So what will be the equation of this common chord? Say this equation of the circle is S1 and this equation is S2. Its equation in sense like you have read equal to zeros, right? And you know, this is the perpendicular. This is the perpendicular from the center, and this side also you can have a perpendicular. This is the radius 1 and this would be the radius 2, right? And if this one is P1, then this will be P2. Like we never know that the distances from the center are equal. If the circles are equal in radii, then the distance from the chord will be equal. The center's distance from the chord will be equal. But here we are taking different radii, so they will be different. So if you take this as P1, this will be P2. Then the equation of the common chord is given by S1 minus S2 is equal to 0. If you subtract the two circle equations, then you get a linear equation, because you know the squares will get cancelled. For example, if you have x square plus y square plus 2g1x plus 2f1y plus c1 is equal to 0, x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0. This is S1 and this is S2. So when you subtract, this will vanish. So you get x times 2x times, you can say g1 minus g2 plus 2y times f1 minus f2 plus c1 minus c2. This is a linear equation in terms of x and y. This will be nothing but the equation of the common chord, because this one is derived from these two. That means this line will satisfy the points on this line, the end points will satisfy the circle, right? So this is the common chord, and the length of the common chord is nothing but this part that is nothing but that's half of it, so 2 times. If you this and this will be equal, right? We know that the line drawn, the perpendicular drawn from the center of the circle to the chord bisects it, right? So 2 times of this one. This is nothing but, by using Pythagoras theorem, root of r1 square minus p1 square will give us the length of the common chord of the circle when you need to find it, right? So now let us try and solve a couple of questions on the equations of these circles, from which we have from the concepts that we have learned so far. Okay, so here the radius of the circle is given as equal to 3 units, and the center of the circle is lying on this one, y is equal to x minus 1, and the circle passes through the point 7, 3. So we have to find the equation of the circle when these conditions are given, right? So let us first draw a circle and see what try to visualize what it is. The radius is 3, and we never know what is the center, but the center lies, this one lies on a point on the line y is equal to x minus 1. So see, y is equal to x minus 1, and generally the center, what do we take the center as? H comma k, where k is the y coordinate, right? So y is equal to x minus 1, so k is equal to h minus 1. So here h comma h minus 1 can be treated as the center of the circle, right? So center is h comma h minus 1. H comma h minus 1 is the center, and then the circle is passing through a point 7, 3, so it is there on it somewhere. So that means this distance is equal to 3, because he gave the radius is equal to 3, right? Now let us see the distance between h comma h minus 1 and another point 7, 3. This distance must be equal to 3, or if you don't apply the square root, it should be equal to 9. Let us try to find it out now. So the distance here, I'm substituting in the formula directly. So 7 minus h whole square plus 3 minus h plus 1 whole square should be equal to 3 square, right? So 7 minus h whole square plus 4 minus h whole square is equal to 9. So we can expand this, 49 plus h square minus 14h plus 16 plus h square minus 8h is equal to 9. So 2h square minus 14 and 8 is minus 22h, then plus 6 plus 49 is 55, so 65 minus 9 equals to 0. So 65 minus 9 is 2h square minus 22h plus 65 minus 9 is 6 and 5, 56, which is equal to 0. So we have to split the middle term and factorize this, but before that we can further simplify it by dividing by 2 on both sides. That gives h square minus 11h plus 28 is equal to 0. Now we have to find the factors of this. So h square minus 4 times 7, so 4h minus 7h. 4h minus 7h is minus 11h and 28. So plus 28 is equal to 0. So h times h minus 4 minus 7 times h minus 4 would be equal to 0. So h minus 4 equals 0 comma h minus 7 would be equal to 0. Then h is equal to 4 comma 7, either 4 or 7. This is the value of h. Then what is the center now? So the center is h comma h minus 1. So the center would be either 4 comma 3 or 7 comma 6. One of these two you can take as the center of the circle. And then what would be the equation of the circle? Like, you know, right, x minus 4 whole square plus y minus 3 whole square. Let me write another thing. So let me copy this center here. The center is 4 comma 3 or 7 comma 6. Then the equation of the circle will be x minus 4 whole square plus y minus 3 whole square is equal to 9, as the radius is given as 3. This is one equation. Or any one of them. See, sometimes they will give one of this equation in the answers. Then if it is a multiple choice question, then you have to check for both of them. Like, that is the reason you need to solve this if it is a multiple choice question. Even you cannot directly pick the answer, because we never know, like, whether he'll give this one or maybe both. X minus 7 whole square plus y minus 6 whole square is equal to 9. So any one of these you can take as the equation of the circle, right? In the second question, the circle passes through 2 points. A is 1 comma 2 and B is 3 comma 4. So first let us draw that. So I don't know where those points will be, so let us simply take 1 comma 2 as A here, and B is 3 comma 4 to visualize, because I'm used to it. Like, if I don't visualize it, I will not be able to solve. And there is a tangent to the circle, like this is a tangent given, so we never know whether this tangent is really here or this side, but I'm just drawing it here to visualize. So this is the center. Let us take it as h comma k. That's the center, right? Now if you look at this, these are the 2 points on the circle, right? So C is the center. So what do we know? CA square is equal to CB square is equal to the radius square, right? And equation of the tangent also is there with us. Now if CA square is equal to CB square, what can we say? See, if you look at this, like, is 1 and 4 and 2 and 3, when you add, you see this addition, like h plus k, if you add those two, what are you getting? See, this is h and k. If you're adding, you get 2 plus 3 is 5. At the same time, 1 plus 4 is 5. So h plus k, I can simply say h plus k is equal to 5. This is one equation for me, right? Next. Or else, you know, you can also equate these two and find it out. Actually, you can, find the distance here, equate them. Then what happens is the terms h square and k squares get cancelled, and you get a simple equation in terms of h plus k. That is, if you do this simplification, you will end up here. Because what happens when you expand this, h square and here k square, here also h square and k square, when you are equating them, the coefficient, there are no coefficients for them, right? X square gets cancelled. Okay, I'll do it for you and show else. It will be h minus 1 whole square plus k minus 2 whole square is same as h minus 3 whole square plus k minus 4 whole square. So this is h square plus 1 minus 2h plus k square plus 4 minus 4k equals to h square plus 9 minus 6h plus k square plus 16 minus 8k. So this h square and k square gets cancelled. So 1 plus 4 is 5. So minus 2h minus 4k plus 5 equals to minus 6h minus 8k plus 25. Now bring all the terms to h and k to one side. So minus 2h plus 6h minus 4k plus 8k equals 25 minus 5. So when you subtract, this is 4h plus 8k is equal 20. So you'll simply get h plus sorry, this is 4k. 8k minus 4k is 4k. So if we divide with 4 on both sides, we simply get h plus k is equal to 5. This is equation 1 from this. Right, so we got this one. Next, this is the equation of the tangent, which is 3x plus y minus 3 equals 0, and this is also the radius. So this distance and this distance will also be equal, right? So what is the distance of a perpendicular distance from a point to the circle, point to a line? So let me write the first equation here. H plus k is equal to 5. Now I have the point h comma k here, and this one is there, the equation 3x plus y minus 3 equals to 0. So what would be this distance equal to? So you need to substitute this in this, right? The distance is equal to, see, the perpendicular distance P is equal to 3h plus k minus 3 by root of 3 square plus 1, right? This would be the distance. Now this is same as the distance between any of these 2 points, right? So here, if this is the distance, and what is our distance between this circle's center h comma k and say the point 1 comma 2. Now if I take this distance, it is square root of h minus 1 whole square plus k minus 2 whole square, and this is same as modulus of 3h plus k minus 3 by root of 3 square plus 1. So if you square on both sides, h minus 1 whole square plus k minus 2 whole square is equal to 3h plus k minus 3 by root 10 whole square. So now you need to simplify this to get the value, to get one more equation in terms of h and k, which you can simplify. Say now h square plus 1 minus 2h plus k square plus 4 minus 4k is equal to 3h plus k minus 3 whole square by 10. So you can cross multiply and simplify to 10h square plus 10 minus 20h plus 10k square plus 40 minus 40k equals to 3h plus k minus 3 whole square. So this one you can again expand using this rule, like a plus b plus c whole square formula. If you use and you expand this, you can get the values of h and k. You will get the value of h and k by simplifying this and our first equation. You can substitute h is equal to 5 minus k in this, and you can find out the values of h and k. Once you have the values of h and k, you can easily find the value of the radius r, and then you can substitute in the equation of circle if you need to find the equation of the circle, right? This may be a little lengthy, but there is no other this one for us. Like, we need to expand this to get the values of h and k, right? So you can do this by yourself. Like, you can expand this and simplify. Once you do this, you get the values of h as 4 and yeah, you might get 2 values. I don't remember the other value, but you will get value 4, and for k you will get 1, and you can find the value of the radius. I hope you can solve this by yourselves. Like, this is just like tedious algebra. It is like you can simply expand. If you want me to expand, I can expand and do it, but I feel like it would be better if you do it by yourselves. So simplified, do it guys by yourselves, and let me do the answer in your feedback. Let me see if you have any questions So I hope you understood how to find out the equations of circles when given, and when given some conditions, and also to find the equation of a common chord when the two circles are given. So let me just quickly recap what we have discussed today. We have learned about the equation of a circle in general form, like when center is given and when center is origin. And also we discussed about the standard form of the circle, like in terms of x means not when separately done by center is given. Say suppose this one, like x square plus y square plus 2gx plus 2fy plus c is equal to 0. So this is one more standard form of the equation, and you can directly find out the radius and center from this without actually completing the squares and stuff. We also learnt about the conditions of circles being tangent to each other, intersecting each other, maybe from externally and as well as internally. And we learned how to find the equation of the common chord of two circles. If S1 is equal to 0 and S2 is also equal to 0, or two equations of circles, then you subtract them, then that will give you the equation of the common chord. And the length of the common chord is nothing but the radius square twice the square root of radius square minus the perpendicular distance from the center. That is simply by using the Pythagoras theorem. Right. So let me know your questions. If you have any in your feedback, we can discuss in our coming session. Till then, signing off, Satish. Thank you.